Welcome in Franco. My name is Tanguy. I'm happy to meet Gwen, the tutor.
Yeah.
Gwen, welcome.
Thank you for having me. It's really cool to see like AFS, producing, your foil like in France. So I'm like very excited to learn everything about how you guys do it.
Yes, I will show you a short story of this factory. We are there since 3 years. We decided to go in this place for different region. I will explain you forward. Before we are beginning the adventure of Franco AFS since 8 years. I will explain you the secret of making high quality proprietary carbon foil.
And so tell me a lot of like other companies like choose to make their foils like overseas. For you, like, what was the driving force for like wanting to make your foils here?
I think it was very interesting to make like a monster garage to have all the stuff for making your parts for bottling. We are specialized in foiling, but it's very interesting to produce our own foil because we can have a control of the quality, control of the design also. It's very important, and we can be very fast on the market when we develop something. And also it's better because we are based in France, in the west of France. We are just, you can see New York is just near us, and most part our customer come from Europe, and I think it's better to produce near the customer. Because you have less transport, less carbon, and it's a good thing for us because we have less parts to buy. We can produce at the demand, and it's good for business. But the main characteristic is the control of our own production and the ability also to have high efficiency R&D on the foil we are producing there. We are also produce board, advanced board, Blackburn. I will show you everything and all the secrets. We are going to see at the beginning what is a prepared carbon.
Okay, let's go. Yeah, so like the first thing I always notice when I see like AFS foils is just like how like visually like nice the carbon looks. So I'm very like curious to see reveal the secret why it looks so good.
Yes, for the AFS foil we use prepared carbon. What is prepared carbon? It's a carbon which is already impregnated by epoxy resin. It's what we call that pre-preg because you are already the resin.
Yeah.
What is nice with pre-preg carbon compared with other carbon, classical, not classical carbon, because when you use carbon you have the sheets of carbon, the cloth, and after you put the resin after in the pre-preg you have the good percentage of resins and
so
the best
accurate and
the best, the maximum percentage of carbon fiber compared to resin, because this is a carbon fiber with doing all the mechanical properties. Those prepared carbon, you use some fresh chamber. You put it,
fridge,
at something like -10, more than -10 degrees,
like
Celsius
freezer,
degrees, and freezer. The carbon, you can have different way to prepare the carbon. You have this one is a ±90. You have also biaxial carbon, is good for friction. And you have also some unidirectional carbon. One of the secrets also in AFS, we are making our pattern, with sometimes 5 axes, especially when we use ultra high modulus carbon, which is called pitch fiber for us. And if we are speaking about the modulus of carbon also, because a lot of people don't know what is SIM, high modulus, ultra high modulus. The modulus is the stiffness of the carbon.
Yeah.
Understand? It's very. But we use some HR carbon, high resistance carbon also. We have very good mechanical properties because it not break, and the ultra stiff carbon, ultra high modulus carbon is very good if you are making some part like mats or like high aspect wing. But also the problem is it's very expensive. To compare the price of carbon, you can have from $30 per square meter to more than $1,000 per square meter. Compared to aluminium, something like $4 per kilogram, and the steel with something like $1 each kilogram. And the carbon is more than 20, 30 the price of the steel, of the aluminium, but it's something like 8 times lighter. That's very good for the sport we are doing. And also a good thing that epoxy carbon is very good to use in marine condition. I will see you how we cut this carbon, because we
you have like special like machines.
Yeah. Those machines are called digital cutter. It's the same machine you can find when you are making some t-shirts in some factory, but the cutter is quite different. There are 4-axis cutter, carbide cutter. It's not cutting by laser, because some people say, because if you are using a laser, you are already it's too hot, and you will see the regime. We will currying the regime with pressure and temperature. So you don't have to put some temperature where you're cutting. And you can see this machine, special machine. We have two digital cutter. It's for the industrial part. If you are losing machine, you are always machine can run it. Because if you are not cutting the carbon part there, nobody can work in the factory. It's the beginning of the factory. Another thing which is very interesting is calling the nesting. We have our own software there in AFS to develop this nesting. The nesting is to imbricate the part to have the less waste, because waste is not good for the planet. It's one important thing also for us, but also because it's very expensive materials. You don't have to put some waste.
Minimize.
You understand? And the nesting also permits you to orientate the parts with the good angle, because you can see this is unidirectional carbon, and those are some stabilizer parts. And we have to need to have the good axis to have the good mechanical properties.
So this one like looks like a Batman or something. Secret.
No, it's not a secret, but it's very precise, and this machine can cut the carbon as less than 0.2 millimeters, and can be very quick. If you try to cutting that part with a knife or something like that, it's horrible. You will pass 2 hours for each floor, and with no precision at all.
Wow.
That's only a pain. It's to be able to recognize all those parts, because after you have to put the part in the good way.
Nice.
Here is the second part of the factory where we'll put all the carbon parts in the mold.
Yeah, so like all of the small like pieces from there, all the layers pretty much.
Yeah.
Are put together. Actually, we can see like pretty well here. Like
it's very circular. It's apart from the silk. With the plate of carbon, you have to make some volume and to put. In the good way. You need to do that very precisely. We have some material to put that precisely. Less than 1 millimeter, even if the carbon will be more fluent, but you have to be very precise. For example, for a silk, it's very important to say the silk is very complicated part. You have more than 89 parts of carbon, like a carbon frame of a VTT carbon frame.
Yeah.
It's very important because you have some monolithic parts, you have only carbon like that. Sandwich part, you can see you have some parts, you put some form, high density form, because you don't need to have solid
It would
parts.
be like too heavy if it was like four.
Exactly, and also for the silk, we are make a lot of work to have the good deformation of the foil and to put the good, the good layup as a good part. It's a very complicated part, and also with the bump. It's
So and is this like a fuselage, like, or like that will be a...
I don't know where it can be. It's a little secret, but not in the fuselage. And after we put that in the mold, you can see that's a pure. Donc it's a plain, it's a pure, okay. And it's the beginning, and we need to do that in not too hot, but I think it's something like 40 degrees, between 40 and 60 degrees Celsius. And we pour the carbon inside, and after we will curing that on the hot press. And you need to be very precise with that.
Yeah, the more like precise you are at this stage, the better, or like easier.
Yeah, it's a better quality. And you can see you have in just this part you can see different kind of carbon. You have the equilibric carbon, the biaxial carbon, the unidirectional carbon, and that's a pitch fiber carbon. That's ultra high modulus carbon. Yeah, you can see. Here is one of the hottest parts in the factory, because
the baking room.
The baking room, exactly. It's quite the same thing like baker, because you need to be precise and respect the recipes.
Yeah, follow the steps.
Yes, to make good parts. And to be able to pour that kind of parts, you can see, fake.
Yeah.
Like, I think you recognize the wing.
Is that like the 900 euro? Or?
Yes, it's no, I think it's 1.1 thousand, yeah, something like that. Yeah. And that's a part directly out from the mold. It's a little bit hot, and to do that we use some hot press. Hot press, we will curing the carbon between something like one and a half an hour or 2 hours, curing this part with hot pressure, something like between 5 to 10 bar of pressure in the mold.
So is this like the resin that was like in the carbon, that's like kind of like leftover that was pressed?
Exactly, the extra resin. And after you will see that as the finishing part, so you will cut that, and after it will be able to. But at this stage, you have only 30% of the work of the wing, because we need to make some preparation, because it's a very good glass. You see that. But if you put this part directly in the water, you will have more than 40% more of drag. It's very draggy if you want to use this kind of direct glass. It would be very nice for us to produce directly that.
It would be easy.
But it's not so easy as that. No. And to do that, we use a press, and that's the part we are the little press. This press is very interesting because I like the low-tech parts. It's like we have. It's like in skateboarding factory or snowboarding factory, we make our own press. We want to have the control of all the stuff, and we are make the plans, we are design. This one was the first one, after we put that, we have the good securities. It's very easy to make the maintenance, and you have all the control. Now we are able to put some automatic feature to control directly the temperature and the pressure of the parts, and to have good parts. And if you have a problem with that, you can find it's very easy to repair that. It's very important because when you are on an industrial project, all the machinery, if you have a problem, you don't have to stop all the production because you have a problem in maintenance.
I mean, obviously you're an engineer, so like this is like the type of stuff that you love to like figure out. Like, but you know, how much of that was like already like kind of like known, and how much of that was like kind of like making your own of like own solution kind of like, is there like some models that you can follow, be like, okay, this is what we need, or you are like, this is what we need to accomplish and this is how we're going to do it?
We have everything is out from our head, but we are inspired by other manufacturing process like skateboarding or okay. But we are making everything. For example, we are make some special feature with directly the secret of the coring. It's directly with the aluminum plates. We have some resistance and we have a good control of resistance. For that, we are win something like 30% of energy by parts. But now we are inspired by all the good things. But it's in France. I love the movement of low-tech technology.
Yeah.
Okay, because you are already thinking what you are able to use and use with intelligence and not to buy. You can find some kind of feature, but it will not as okay like that. And when we develop some kind of machine, we win a lot in the production. It's better for the maintenance. It's good for everything, and it's good for the planet. Oh, just look at that. Yeah, when I speak, you have because it's hot. Yeah. It's just out from the mold. It's what I say. These are the base plates, and you can see it's a chop rag. It's all the
leftover.
Yeah,
the
exactly.
Leftover pieces from where we saw like the machine cutting it, and then put together, and we can see like all the different.
It's a chop carbon preg. Some people say that's no forged carbon.
Yeah.
And it's we use that kind of technique 6 years. A lot of people come at this technique.
Yeah.
And it's very good because you don't have to put all the waste, and it's not quite.
Recycling the small pieces that were otherwise going to trash.
Exactly. It's not as simple like that. You don't put only the tricky part. You have to make a retreatment of the carbon.
Yeah.
But that works very well, and it's very good because it's on anisotropic parts. You have the effort in all the way because it's at the top of the mast, and that's a good stuff to have the carbon in all the direction.
Arriving with the birds, I recognize the blackbird here.
Yeah, it's a secret. It's a blackbird victory. Well, I think when the video will arrive, you see that. But yes, it is quite different. We don't use prepreg carbon. We use some classical carbon with a vacuum. Donc you have to put these closures and to prepare the resin, the epoxy resin after. Donc here it's a little factory for make our full carbon downwind board. So this is the Blackbird V3, the first are building there. And for this board, also full carbon board. You have a sandwich part there, you can see that because all the carbon we put in that. And there is a little production. We want to increase the production at the end of the year, because here we are able to produce something like between 12 and maybe a little more board each week. Okay, it's an activity we are beginning 2 years ago with the first Blackbird, and we want to increase this activity because it's a good way to buy some very high quality board like that. You can see you have only a little glass just there. Because that all is full carbon board, because we need to be stiff and lighter for this kind of board. We have also made the pro board, we have freestyle board, but with that. And you can see inside we have put some foam between 20 kilograms per cube meter or just less. And this is a prototype for. Donc there we make the prototype of the board. We make the production of the the good quality Blackbird, for example. And after all the board coming from AFS, not coming from the factory, we are also working with Terminatech, who is based in Tunisia.
Yeah.
But the full carbon board I make there.
Yeah.
It's a lot of technology and handcrafted aussi, like the glass part. This is, I don't know, this is the first prototype of the Blackbird V2.
Oh, okay.
Yeah, you recognize that?
Yeah.
And we make some stuff like that.
Yeah.
But it was very tuning, look at that. Do that, but no.
Yeah.
What's the board for Richard? This board are exactly 1 year.
Oh,
Because you have produced that board at the first Croissant Open Festival with the famous now downwinding competition.
Yeah.
You have the Molokai, the Croissant Festival in France, and we are happy to have that. It's just at 20 kilometers from the factory.
Nice.
Here is a little bit noisy, okay? We are at the finishing place. All the foil on the board comes there because you have seen the parts arrive with a little more some resins. First of all, you will see after we will see that it's cutting by a machine, by a CNC machine. To be very precise, especially when you have a mask. It's a little bit easy because it's not easy, but when you see the bump design we use on the Enduro, on the silk, you need to be very precise. Donc at this stage, all the things are made by mechanical stuff, and after we are using a lot of handcrafted machine to sand the foil.
Yeah.
The purpose to sand the foil is to have the good surface finishing for the performance of the foil. I said if we want to have the classic glass of epoxy, you have more than 30% more drag, and we need to have the good surface finishing. And also for the aesthetic problem, some parts we put some varnish, some parts are only sanding, and that's it. When I speak about machinery, if you are to do that, because you need to be very, very precise on the leading edge to cut that, because it's very hard if you have to do that manually. The CNC machine is right now. And also on the trailing edge, it's very important, the trailing edge. Each week we produce more than 300 parts of carbon plant. Not foil, not 300 foil, but 300 parts. And I think these are more than 100 foil each. And that's the last embittement we are doing. This is a robot who are sanding for the moment the mat. And we are developing that because I think it's very interesting to be aware, because when you have a factory in Europe, you know the main, not the main problem, because not a problem, because but the salary are higher than Asia. Donc you need to find the good solution between machinery and handcrafted.
Yeah.
Okay. And that is cool because for the first part of sanding, it's not very cool.
Yeah, it's not an enjoyable job to be sanding all the time. Yeah. So if a machine could do it, they would be.
I think this is one of the future of the production part in Europe, in US. The robots on the robotics also, the collaborative robots are very nice. And it's a good project, and we expect, I think we will buy, something like 5 or 6 robots next year. Yeah. Oh, there is a little bit noisy, okay? We go to see the machinery. We have 4 CNC machines. We are dedicated to cut carbon parts, foam parts, to make the prototype or to cut the foam for the board. So this machine, this CNC, is cutting very precisely the part in less than 0.1 millimeters. Yeah.
So yes, you wouldn't be able to really do that by hand, being as accurate.
And make the drill. By hand, sometimes we make the prototype, but it's always precise.
Yeah, yeah.
You need to put the place very precisely because the machine is very precise, but you need to put the wing of the prototype. and also drills a hole to put the insert inside. That's the first CNC we have. This one I'm more than 8 years. It works perfectly. This one only cut form, the little one. Donc ça, it's to make the sandwich part. It's for the Arduino, you recognize the bump. And all the people who are working there, we have also a lot of people not coming from the composite industry. You have, it's quite a school in Poland. Okay?
Yeah.
This one, you can see the aluminium because this one is bigger, and we can make all the mold, or we also make the prototype. That's a mold for the prototype stabilizer. Here, because we're in the factory, we can be very quick to make a prototype. Between the idea, the 3D model, and the building and the test, when we are good, we can have for a stabilizer something like 36 hours, 1.5 days from the idea to test the prototype on the water. For bigger foil, it's more than that. And that's our biggest sense is to make to cut the form to put inside the board. It's quite big noisy. It's a good machine. You have automatically tool change, and it's very fast machine.
Yeah, and I see
faster than the conventional model you can find on the market. It's why we are decided to company design.
I see like everything is like organized by specific material. So what's
No, organized because we have treating all the waste.
yeah.
Okay, that's the aluminium coming from the mold. It will come back, but we're also, you can see all the forms, the EPS form go back to the factory, and we make a new model.
Yeah, so everything is, all the waste is separated and recycled.
My dream is to have a zero waste factory. We are not at that. I think we have something like 10%
waste. Yeah.
I want to tell it. It's not easy to do that, but it's one of the part of the mindset of this factory. You know, Gwen, when you said why I put also a factory in Europe, it's in Britain, is because we need to be near the customer.
Yeah.
It's better for the planet, but also all what we want to do with less consumption, with the waste is. I think in water sports we have always put an imaging of nature and we need to be better and better in the production of the parts.
Yeah.
I have 4 children. I want that my 4 children have the same image of the planet since 10 or 20 years. We're at the beginning of the road, but we try to make most parts of Portugal with no greenwashing.
So I mean, it is like, you know, we do what we do on the water, you know, because we have access to all of that, and we can't just like, you know, be like hypocrite and not care about it or like just enjoy it. So like you receive when we go in the water, you know, we have fun, we receive, but we also need to give back, and we need to make sure that that opportunity is available to everybody for a long time. So it's important.
Well, this is the last part of the factory. This is stock. We put all the board. You have a big board because we will make a lot of school board, also paddle board. The wing, the foil, everything. And you need to have a stock because when you sell something, you need to have a stock.
Yeah.
And that's the specific part, the specific stock for the board, and the specific stock for the foils. We have not a lot of foil because one our main advantage there is to be able to predict when you have a command, to have not a lot of stock, because when you have a lot of stock, you have a lot of money who are sleeping, and then we can be very quite speed when you are producing some foil. You can see the race mast 90. I don't know. You are not protecting a race wing foil now. Very fast, or full pitch fiber mast 95 one. And there are the logistical parts also, because we are putting parts everywhere in France, Europe, US, in the world. We're putting parts in US, Thailand, France, Martinique also for the France. That's good. I think there every week we put more than something like 100 foils each week from this factory.
Wow.
Yes, it's big.
Yeah. Well, I mean, to me, like, it's really like amazing to see, that it is possible to make, your foils like locally, which, often is an argument that, maybe other brands like, are saying is like, no, you can't do it because of like, costs of labor and everything. So, I really love that like you guys are able to make it happen here in France, and then also being very active in like being mindful of like the waste, the ways you do things, how to recycle and have the lowest impact. I'm very impressed by what you guys have created, and can't wait to see how it expands.
Thank you, but it's a lot of work. You have to know the 8 years we are working a lot to do that. And now what is interesting also is maybe in the future we will be able to put this model in other countries also, because we want to expand the activity maybe in other countries. No, it's a good way, and also it's economically speaking, it's very interesting to do that, because we can see our industry was very impacted by the stock, for stock, and when you are producing only the good amount of product you need, no problem. When you are working in Asia, especially China, you have to buy with MOQ quantities a lot of parts, and nowadays, especially with social media, it's very hard to have a provision of one. It's impossible.
And the sport is still like fairly new, so like things do evolve very quick, and it's I mean, for the consumer too, like it's hard to buy something when you know that like maybe it's going to be like much different, or so it's a very fast changing. But I also noticed that like you guys are like testing some new thing kind of like out of the box, and so that's pretty interesting.
But you have the chance to see that, because a lot of foil producers have never seen the factory where they're buying their foil. I think it will be interesting for them to see that we can do that. But thank you, Gwen.
Thank you so much.
And see you on the water.
Sounds good.